Hello, today we'll talk about functions and the control that they have. To begin with, let's actually start by writing a function. Now, a function has a few parts. Let's start with a new one. Let's get a function having a few parts. So let's call it the doubler function. Something a little simple here to start us out with. A function has a def keyword. It has a name. In this case, I call it the doubler. And some parameters. It may have 0 or more parameters. You can have as many as you want in there, or none. And then there's a piece of syntax, a colon, to indicate that we're at the end of the header. And indented is the suite of the header. And let's just do something like y equals 2 times our parameter x. And we'll return a value. We'll return the y. So functions should be familiar from mathematics. They take an argument, in this case x, do some calculation, in this case y equals 2 times x, and then return some value. Functions return one thing. That one thing can be extremely complicated, can be a whole list of things or whatever, but it is one thing, even though that one thing that is returned may have many, many parts to it. The return is actually optional. You can have a function, say that I can have it print y as opposed to returning y. And later on we'll take a look that you can have multiple return statements. So here's our simple function. Let's call it let's put it in the right place. Oops. And we'll call it the doubler. And always remember to put the py at the end, otherwise we lose our coloring. Got a little issue in terms of size of things on my Mac here. So there we have our simple little function. Execute it. We have function F5. And let's take a look. First thing you'll notice is nothing happened when I hit the start of the program. And so what happened was the doubler simply got loaded into the shell. So it's there for us to use. We see we get the hint that it has one parameter x. Let's give it a 4, and we see that we expect 4 to be doubled, and we have a value of 8. Now it would be nice to give us a little more information. So let's put in a special comment here. That tells us what goes on doubles x. Very interesting, but it does at least tell us a little bit more about what this function does. Now let's take, and we may give information like, oh, x should be where x is an int, float, or string. How about we do something like that? Save it. Actually, so we can get back so we can read that again. And now we'll load that into the shell. Now let's see, we get a bit more information. So not only does it tell us that it wants x as an argument, but it also tells us that we'd like the x to be an int, a float, or a string, because that's in fact what we're dealing with here. It doesn't change how the program operates. It operates just like it did before. We can put a float in there. It doubles that. And in fact, we can even put a string in there. And remember, with strings, multiplication is defined. It does concatenation. Now let's talk a little bit about the argument and parameter. First of all, when we're calling the function, as we are here in the shell, we call what goes between parentheses the argument. That comes straight out of mathematics. In the function description itself, in the upper right corner there, or it's also called, it's more properly called the function definition, we refer to the x in there as the parameter. So it's argument when we call it, it's parameter in the definition. Those come straight out of mathematics and hopefully are familiar terms to you. Now let's take a look at that. Suppose I have an x, give it a value of 4, and now I go doubler of x. We see that it returns an x. It returns an 8, just as it did before. But note that if I print x, it never changed. So even though my function has gone off and doubled the value of x and returned a value of 8, the x itself hasn't changed. Okay, maybe that's not very surprising. Let's take y. Y has a value of 0. And now let's do doubler of x. And we see, of course, an 8 is printed, but 8 in our function definition, y actually had a value of 8, and that's what was returned. But what happens if I print y? And we see that y in the shell is still 0. So what happened was, when the function was called, the doubler x, the 4x, remember x has a value of 4, let's print x just to see that. That 4 is passed as an argument to the parameter x. And this is actually a different x. It's the x that's in the function. And we double that value, and there's a y in the function. That's a different y than the y in the shell. So when I doubled that and it had a value of x, that didn't change the y in the shell. The reason is that the function has its own namespace. So the x and the y in the function are in a separate namespace. And when I make changes to the x and the y in the functions, they have no effect. They don't change the x and the y in the shell. Now we see this happening because my x's and y's are immutables. Later on, we will learn that mutables, which we haven't seen any of yet, will in fact behave differently. Our returned, now let's go back and play with the function a little bit. Our returned value could be captured in a variable. So if I so I can grab the 8, the value of y 8, which was returned, I assign to a z. So z gets the 8, and then I can print it. Now let's take this a step further. Let's go back to our program, and let's put into the program some of the code that we've done. So we say x equals 4, doubler of x. Now let's even go, let's capture that value, and then we will print x and z. So now my function has a little bit more, now my program has a little more in it. It starts off with a definition of the function, and then we have the main part of the program, x equals 4, z is assigned the doubler of x, and then we print x and z. Control in this program starts with the x equals 4, And then we see the doubler on the right-hand side of the equal sign. So we call that function, passing it the argument 4. Remembering that our function has its own namespace, so that's a new x in there, and a y. Hey, let's put a y in here. Y equals 0, just to help show that. So we will print x, y, and z, and we'll see that the x and the y in the main part of the program are not changed by the doubler. So let's run this program. And it prints the value of x, which is 4, which never changed, the value of 0, y, which is 0. That printing is happening in the main program. And of course the z, which is returned. Let's put a print of x and y in my my program, and let's put the print of the x and y in the function. Let's see what happens there. Now we see that the x and y are printed. Y has a value of 8 in the function's namespace, but it has a value of 0 in the main program's namespace. X has a value of 4 in both, but that's simply a coincidence. They're actually two different x's, and they just happen to have the same value. Let's make one final change to our program. Let's show what happens if we have multiple returns. Let's do something silly, like if x is greater than 0, then we can actually, let's just simplify this whole thing. I could rewrite the program as it exists right now and never use a y, and simply return 2 times x. We see that it works exactly the same way. So I didn't need to have the y equals 2x. Now let's change this a little bit. So if I have x is greater than 0, I'll return 2 times x. Else, let's return negative 2 times x. And let's play with this in the shell. We'll get rid of that. So we run our program. Of course, nothing happens. Doubler of a 4 returns an 8. Doubler of a negative 4 now should also return an 8. So we see two different returns. Only one is executed. It's the first one you come across. We can have as many returns as we want, or we can have no return. Very quickly, what might I do with no return? Let's just print something. Print 2 times, 2 times x. Save that. Run that program. Doubler prints an x. Prints the 2 times x. It almost looks like it does the same thing, but it really just does a print of it. We can help that out and put printing something like that. So now we can really see that when I run that doubler of 4, it says printing 8. So there's functions. We have arguments passed into parameters. We have a separate namespace in the function, and we can have anywhere from 0 to any number of returns.